So I've recently had access to a 3D printer, and it's really cool how many 3D parts and models are out there free for you to print into real life. I am an instrument-rated commercial pilot, currently training to be a flight instructor, and so I've come across Vortex Generators before as used on aircraft wings. I logged a dozen hours in a Piper Super Cub with VGs installed on its wings. But what do these things actually do? Let's take a minute to see how moving air reacts with a solid object. Because air has friction, or viscosity, it can act a little bit sticky, not nearly as much as honey or oil, but it's there. And if you have a free stream of air moving along a solid surface, the air next to that surface gets slowed down by it, and that friction propagates upward. This area of slowed down air is known as the boundary layer, and it's why you can never quite blow all the dust off of things. As air flows around a curved surface, it would like to follow that surface all the way around. If air did not have any friction, it would flow around this ball symmetrically, high pressure at the front and back, low pressure at the top and bottom, and there would be no drag because the pressures are symmetrical and there is no friction. However, what you actually get in real life is a wake. This right here is particularly interesting because the air is going from an area of low pressure to an area of greater pressure, and that's kind of weird because things always want to go from a higher pressure to a lower pressure, but the air has enough speed and momentum to push through it. With no friction, the air would conserve all of its energy from accelerating around the ball, and have just enough to leave the other side at the same speed that it started at. But since it has been slowed down by friction, the boundary layer doesn't have enough energy to push through. It slows down to a halt and then actually starts to go the other way at the surface. And right there, that is when the airflow separates, and that area of reversed flow is called a separation bubble, where air is recirculating and it has a lower pressure. And the difference in pressure between the high ram air pressure in front and the low pressure separation bubble in back causes a force known as pressure drag. Another way to look at it is that the air has mass, it has weight and momentum, and at the front of the object there is a point called the stagnation point, where the air is compressed and the velocity is brought to zero. It's like we are constantly grabbing air and pushing it with us. Similarly, the wake in the back is a low pressure separation bubble where we are grabbing a bunch of air and pulling it with us. We are giving it some of our energy and then letting it go and then grabbing some more. I noticed that the raindrops on my car's rear windshield wouldn't get blown off when I would go down the freeway, indicating that the air has separated and was not attached. So I thought it'd be a cool idea to try and 3D print some vortex generators and then put them on my car's rear windshield and see if they would help delay airflow separation. Here is my test. As you can see, without the VGs, the telltales are swirling all over the place from the circulating currents in the separation bubble behind my windshield. With the VGs installed above the middle section of the window, we see a huge improvement. This theoretically reduces pressure drag, however it does increase lift at the rear wheels, which reduces traction. But how do these vortex generators work? When air is being redirected around an object like a piece of plywood or maybe an airplane wing, and lift is being generated, there is a lower pressure on top and a higher pressure on bottom, and this higher pressure can escape to the low pressure around the wingtip. This causes all the high pressure air to move outward and all the low pressure air to move inward. These sheets of air are called vortex sheets, and at the tip they roll up into a vortex. And so a vortex generator is just a little wingtip pointed up through the boundary layer, mixing the layers. The air on the high pressure side is moving upward and the low pressure side moving downward, and at the tip it rolls up into a vortex, mixing the air from above the boundary layer with air inside the boundary layer and preventing it from staying close to the surface for too long. I also briefly tried putting these on the outer wings of my latest scratch-built RC plane, and I could definitely tell a difference. It just felt safer and more controllable at low speeds. The inner wing would easily stall, but the outer wing would maintain control. It's pretty interesting how you can actually hear the wake of the wing. At high speeds and low angles of attack, the air is smooth, but at low speeds and high angles of attack, the wing's turbulent wake is hitting the tail surfaces and the camera. I velcroed my APM 2.6 autopilot as a data logger, hoping to measure the difference in stall speed, but then I was quickly reminded that I have no idea how to use this thing. All the virtual wind tunnel stuff was recorded on my computer using Autodesk Flow Design, and all outside sources are linked in the description. I made a similar video with a similar topic if you want to see it here, and if you want to see how I made this airplane, I made a video about that last week. I am not an aerospace engineer, and I've taken a minimum amount of math. I just like to try and understand and visualize how the world works and make connections. Please comment and let me know what you thought.